Good morning, everyone. We were in module number 3 of Computer Communication Network, and we were discussing about network layer. So, in the previous lecture, we have learned some of the facilities or services provided by network layer. So, while discussing about the different services provided, we have seen how network layer will perform packetization followed by routing and forwarding. So, as we learned in forwarding and routing, switching plays a major role. In the network layer, packet switching is used to switch the packet from one network to another network. So, we were discussing about the different switching types in case of network layer. So, as we learned in previous lecture, there are two approaches in case of packet switching. One is datagram approach, second one is virtual circuit approach. Datagram approach is a one wherein it is also called as connectionless service, in which the data whatever is received from the transport layer, that will be fragmented, in the sense the data will be sliced and it will be forwarded to the destination. So based on the number of routers available in the path, the packet might use any possible way. So all the packets may not use the same path for traveling. So depending upon the traffic and the entry in the routing table or the forwarding table, the packet will move from the source to the destination. So there will not be any predefined path from the source to the destination. So each routers in this case see the destination address, and based on that the packet will be forwarded. So this is what we have studied in previous lecture. With this basics, let us move on to the second type of packet switching, which is called as virtual circuit approach or connection oriented service. So if you just remember, the datagram approach was connectionless service, whereas virtual circuit approach is connection oriented service. In virtual circuit approach or connection oriented service, there is a link or a relation between all the packet belonging to a message. That is, whatever the entire data that network layer will get from the transport layer, and when it is divided into multiple packets, all these packets of a one particular message will have a relationship. In this case, before all the datagram in a message is transmitted, initially a virtual connection is established between the source and the destination. As you can see, there is a path from the source to the destination. So this will be established in the beginning, so that exact path for the datagram is defined. So datagram will be knowing the exact path to be followed to reach the destination. So once the path is set up or connection is done, datagram will follow the same path to reach the destination. So in case of virtual circuit approach, along with the address of the source as well as the destination, the packet should also contain flow label, that is the information containing which path to be followed should be mentioned. So based on these three data, that is source address, destination address, as well as the flow label, the packet will be forwarded from the source to the destination. So you can see here I have taken the same diagram which I have taken for the explanation of datagram approach. So there is a moment of flow. So this has got multiple path like R1, R2, R4, or R1, R4 through R5, R1, R3, R4. So you have multiple option to reach the destination. So this we have seen in case of datagram approach. Okay. Here, as we said, in case of virtual circuit approach, initially the path has to be created. Then only the data will be transmitted. So, in order to create this path, in case of this virtual circuit approach, there are three phases. So, the first phase we call it as setup phase where the connection is established. Second phase is data transfer. Third one is tear down. So, in the setup phase, as I said, the source and destination address of the sender and the receivers are used to make the table entry for the connection oriented services. Second phase is, as I said, data transfer, where the data is transferred from the source to the destination. And the last one is tear down phase, that is the source address and destination information which is there in the router will be deleted. So these are the three different phases used whenever a connection oriented service is used. So I repeat, the first phase is setup, second one is data transfer, third one is tear down. Setup, to set up the connection between the source and the destination. Data transfer, to transfer the frames, and last one is tear down, to delete the address of the source as well as destination from the routing table. So we'll see all these three phases one by one now. The first one is setup phase. So in the first phase, that is the setup phase, the router creates an entry for the virtual circuit. For example, suppose in this case you can see A, that is the source A, need to create a virtual circuit to destination B, from here A to B. Then it is going to create or send two auxiliary packets to be exchanged between the source and the destination. I repeat, in setup phase, a router creates an entry for a virtual circuit. In this case, suppose A, that is source A, need to create a virtual circuit to destination B. Then two auxiliary packets or two packets, testing packets, to be exchanged between source A and B. So in order to create a virtual path, initially there will be two packets exchanged between the source and the destination. Okay, the request packet as well as the acknowledgement packet. So the two packets are, one is virtual, that is, one is request packet and one more is acknowledgement packet. So let us see what is this request packet and acknowledgement packet using this particular diagram. As I said, so we have two packet, one is request packet and acknowledgement packet. So we'll see about request packet first. So as you can see in this diagram, source A want to send a request packet to router A. So initially the packet will be sent from A. So source A send a request packet to router 1. This is the first step. So first step is to send the data packet from A to R1. So now router R1 receives this request packet. It knows that packet goes from A to B, goes out through port 3. So this is the connection to go from A to B. However, the router assigns the incoming port, that is here you can see in this table, 1, and chooses an available incoming label. So here the incoming label available is 14 and the outgoing port 3. So this has been entered in the routing table. Okay, so it is going to assign the port and the corresponding label. Similarly, it is going to assign the output port. Remember, the label for output port is not mentioned now, and that outgoing label which will be found or it will be calculated during acknowledgement step. So after this, once this data has been entered, now the packet will be transferred to router R3. So now router R3 takes the request packet. So once again it is going to check the input port and it is going to assign the label for the incoming packet, and it will enter the port address, that is outgoing port address, and once again this label will be kept empty. As I said, this will be entered when the acknowledgement frame will come into this particular router. Once this is done, it will be forwarded to router 4. So router 4 receives the request packet. Again, once again it enters this three column, that is incoming port and label and outgoing port, and all this data has been entered. Then it is going to transfer to the destination. So destination b receives the setup packet, and if it is ready to receive the packet from A, so that is what are the actual data is to be sent. If it is B is ready to receive those this data, it assigns the label to the incoming frame. So it is going to assign the label to the incoming packet that comes from A. So you can see that in the next diagram. So you can see here it has assigned the number, so incoming for the frame, so that has been labeled as 77. So then this label will be the destination label, and this label lets the destination know that the packet has come from A and not from any other sources. So this is the unique number given to that particular label. So now the request packet has been sent from the source A to source B. So in response to this, the destination B has to send an acknowledgement packet. So it has to be originate from B and it should move towards the source A. The task of this packet is to complete the entries in the switching table. So we have seen only three fields in the routing table has been entered and one was kept blank. So this acknowledgement frame, while moving backward, it's going to enter this data in the routing table. So now the destination, that is B, sends an acknowledgement to router 4. So that is the one which is connected to the destination. The acknowledgement carries, or the frame that carries, the global source and the destination address, so that the router will come to know which entry in the table is to be completed. So where the data has to be entered will come to know through this source and the destination address. The packet also carries the label 77, that is the address label given, chosen by the destination as the incoming label for the packet from A. So that has been labeled here. Router R4 uses this label to complete the outgoing label column of its particular entry, and then it will be moved forward to R3. So now the router R3 perform the same operation wherein it is going to add its label. So in this case the label is 22, and that will be, once the entry is done, then the acknowledgement frame will be forwarded to router R1 as shown here. So from R3 it will go to R1. So the router R1 will enter, or it will make the note of incoming label in its table chosen for the setup phase, and then uses this for outgoing label in the table. So it has entered 66 here, and now then it will forward it to the source here A. So when this comes, or R1 sends the acknowledgement to source A that contains its incoming label in the table chosen in the setup phase. So the source uses this as an outgoing label for the data packet to be sent to the final destination. So in setup phase, first the packet will be sent, that is the request packet will be sent from source to the destination through all the routers, and when it moves from one router to another, it will note down the incoming port, that is the packet from which port it has got, and it is going to give a label, and also it will make a note of outgoing port while setup. So this will continue till this packet, that is the request packet, reaches to the destination. Once it reaches the destination, it is in return to request packet, it generates a acknowledgement packet. So this acknowledgement packet will move from destination to the source, and while moving from destination to the source, in between whatever the routers are there, it is going to give its outgoing label. So all the entries in the routing table will be updated, that is the outgoing label will be updated while it moves from destination to source. So now the incoming port as well as outgoing port, everything is set up in the setup phase. So the datagram or the packet will be knowing in which particular path the data has to flow, that is which is the incoming path and which is the outgoing path will be known, or it will fixed up in the setup phase. So once the setup phase is done, the next one is data transfer phase. So in this phase, the data has to be transferred from the source to the destination. So after all the routers have created their forwarding table for a specific virtual circuit, then the network layer packets belonging to one particular message will be sent one after the other. So one by one, a packet related to one particular message will be transferred from the source through the routers. So you can see in this particular diagram. So it is going to send a frame or the packet which consists of source address, destination address, and the actual data, and it contains the incoming label. Okay, so you can see how the packet will flow through this particular virtual network. So in this diagram, a flow of a one particular packet we have shown here, but the same process will continue for any number of packets. So it may be one or it may be 100. So the source computer uses the label 14 which it has received from the router 1 in the setup phase. So router R1 forward the packet to the next immediate router, that is R3, but changes the label to 66. So that is the data which it has got. So router R3 forward the packet to the next router, that is R4, and changes the label to 22, and finally router R4 delivers the packet to the final destination with the label 77. So all packets in the message flow this or follow the same sequence of label, and packet arrives in order at the destination. So the packet from the source to the destination one by one will follow the same path and it will reach the destination. And whenever the data is transferred from source to the destination, each time the router is going to check its incoming port as well as outgoing port and its label. Through that it is going to send, unless like datagram uh, approach, here it is a path is fixed. So that is one advantage, wherein all the packet will reach in the same sequence in which that packet has been sent. For example, if packet first, that is one, is sent, then first will reach, then the second, then the third, then the fourth. So the packet will follow the same path, and at the destination the receiver has to collect all the data. They have to arrange in the same sequence number, and it has to be given to the transport layer for the next operation. So we have seen the first two phases. The first one is setup phase, second one is data transfer phase. So once this transfer takes place, finally the third phase comes into picture, which is called as tear down phase. So this is the phase wherein the connection between the source as well as the destination will be terminated. So in tear, tear down phase, source A, after sending all the packets to B, sends a special packet called a tear down packet. So that is, source is going to send a packet called tear down packet, which will be indicating the destination that whatever the data it wanted to transfer, it has been done now. So now the time to disconnect. So this particular frame or the packet we call it as tear down packet. So once this is transmitted, once it is sent to the destination is going to respond with a confirmation packet or something like an acknowledgement. So it is going to show, or it is going to give a confirmation to source A, saying that yes, it has got a tear down packet. So now we can officially uh, shut down, or we can remove the connection between the source and the destination. Once this confirmation packet has been received at the source, so all the routers in the particular path, so whatever the routers which has been used in between the source and the destination, all this are going to delete the entries in the table. So we had seen each table had an entry, right? So since the data transfer has been taken place, then for the how now the data is not required. So it has to have, or it has to create a new data or new entries for the any new data transfer. So it is going to delete all its old data and it will wait for the new data transfer to takes place. So we have seen the packet switching method in that virtual circuit approach. So this will be the end of introduction to network layer. So till now we have seen the task performed by or the whatever the different services provided by the network layer. So followed by even we have learned the different types of addressing method used in network layer. So we have seen IPv4 addressing scheme, how it can be written and how it can be used in giving the or assigning the address. So with this, we'll move on to the next topic, which is called as dynamic host configuration protocol. So we have seen how the addressing will be done in case of network layer. So uh, here is a method wherein an organization can automatically assign an address using a method called dynamic host configuration protocol. So it is a protocol which is used in network layer for assigning the address automatically in an organization. So we'll see that in the next video. Thank you.